Thank you very much. Ladies and gentlemen, thank you so much for inviting me back. I'm going to give you a plot. Not only do you have a milestone here in New Galloway, you also have a wonderful town hall. And the most important part of the town hall is the clock on your tower. And you're almost unique in Scotland. I travel the length and breadth of Scotland, and I always get annoyed when the clock on the town hall is at the wrong time. Yours are spot on. It's just about 3 o'clock. Spot on. Thank you. And thanks for inviting me to return to our Glenkens story event. I much enjoyed my visit in September 2022 when we celebrated the bicentenary of the Ken Bridge. And as Mike said, the life and works of its designer, the Scottish engineer, John Rennie. Today we're celebrating another major engineering feat in Glenkens, the 90th anniversary of the Galloway Hydro-Electric Scheme, opened in 1936. Now, as I did with the Ken Bridge presentation, I'll caveat this talk by reiterating that this is not a civil engineering lecture. I'm not an engineer of any persuasion. I'm merely a retired chartered surveyor and environmentalist, but one with a keen interest in Scottish history and geography, and how the heritage has woven its pattern across a rich and diverse landscape. I tell stories, but what a story I'm here to relate this afternoon. Now, in an era when renewables play a critical part in the delivery of green, sustainable energy as we progress towards net zero and to address the challenges of climate change, we've an impressive record in Scotland in harnessing both the water and the wind resources. According to the Scottish Government, in 2022, the country generated enough renewable energy to power all the households in the country for 3 years and exported electricity to England, that surplus 13%, worth a value of £2.4 billion. Now, ask most Scots to identify the infrastructure delivering this renewable energy. They'll doubtlessly point to the myriad of wind farms generating electricity both onshore and offshore, and to the impressive network of hydroelectric power stations throughout the Highlands, using pumped storage as a means of recycling our water resource to best effect. The work of the tunnel tigers from the 1940s right through to the 1950s and 60s, this is 1955 at Breadalbin, means that the water which generates electricity at Pitlochry has already generated electricity 5 times before it reaches Pitlochry. And they carved 780,000 cubic feet of solid rock from within Ben Cruachan at Loch Awe to create the world's first hollow mountain to generate hydroelectric power. That was in 1965. But you know, in generating the hydropower on a significant scale, Galloway got there before them. And it's still operating today. The Galloway Hydro-Electric Scheme was conceived in the 1920s. It was built in the 1930s, and today has a capacity to generate 110 megawatts of total power, peak power. The present owner, Drax, has maintained it, extended it in part, and brought its electronics up into the digital age. But it's basically a wonderful example of Scottish engineering at its finest, part of our heritage, working for us in the 21st century. Now, in terms of stature, the Galloway Hydro Scheme is up there with the more celebrated civil engineering triumphs in Scotland. Like here, the fourth bridge. Here it is, from 1890. The Loch Catchin Water Supply Scheme for Glasgow from the second half of the 19th century. The hydro schemes in the Highlands, that's Pitlochry. From the Falkirk Wheel, you know, the largest rotating boat lift in the world, completed in 2002. And of course, the Queen's Ferry Crossing from 2017, the longest pair of freestanding cantilevers ever constructed anywhere. Well, Galloway is up in that league. It's often said that Galloway is Scotland's forgotten gem. And if the Galloway hoard attracts more public attention, the Galloway Hydro Scheme is certainly one of its other jewels in the crown. And that's what we're here to celebrate this afternoon. Along the way, we'll meet several of the key figures who helped create this jewel. Basically, in a nutshell, water is resourced from a catchment area of some 400 square miles, from the principal river systems, the Ken and the Dee, through reservoirs, including those at Loch Doon, Carsfad, Clattering Shaws and Tongland. There are 6 generating stations, Glenlee and Tongland, date from 1935. Earlston, Carsfad here, and Glenkens date from 1936. Drumjohn was added in 1985. There are a total of 11 dams, 8 miles of pipelines, aqueducts, tunnels and canal, and a massive barrage gate at Glenlocher, not to mention cofferdams, siphons, surge shafts and overflow spillways. We're going to look at some of that infrastructure in a few moments, but the principal difference between the Galloway scheme and the Highland Hydro-Electric schemes was that the Galloway scheme is what they call a run-of-the-river scheme, rather than a pumped storage operation. Galloway is gravity-led system. The head of water created by the natural topography and the physical features, adapted by strategically placed dams to create reservoirs and tunnels, spillways and so on, designed so that the turbines would generate electricity efficiently and effectively. The time of the Galloway development of the 1930s could not have been better. In 1925, Lord Weir, the Scottish politician and industrialist, recommended the creation of a central electricity board to link the United Kingdom's most efficiently efficient power stations with the consumers, on what he called a national grid iron. The system was established in 1926 to standardise the UK's electricity supply, and in 1935, the national grid was born. Weir's vision for the commercial operation of the national 132 kilovolt electric power transmission grid had become a reality. Moreover, ladies and gentlemen, it was the first integrated national grid anywhere in the world. William Douglas Weir here was born in Glasgow in 1877. He's the first of several Scots that we're going to meet on our journey this afternoon through Galloway. William's father James and his uncle George founded G and J Weir in 1871. Reputedly, the family is descended from Robert Burns, but that branch of the family were technology whizzes when it came to inventing pumping equipment, primarily for the steamships being built on the Clyde. I defy anybody here this afternoon to say that they've never heard of Weir Pumps, a multinational company which celebrated its 150th birthday in 2021, and of course, still headquartered in Glasgow. The hydroelectricity which began to be generated at Galloway in 1936 was a very significant player in that newly created national grid. I'm going to say the trump card. I don't know if you're allowed to say trump card now. In the old-fashioned sense of the word, the trump card was that it could be turned on and off very quickly to meet peak demands. And that was unlike the oil and the gas-fired power stations. And that ability proved a real strength during winter periods of heavy demand. Now, it's important to recognise that the Galloway scheme wasn't in fact the first large-scale use of hydropower to generate clean renewable energy for public supply in the UK. However, that honour does go to another Scottish facility. This is it. It's the Lanark Hydro-Electric Scheme, which was commissioned in 1926. It's a run-of-the-river scheme, just like the Galloway scheme, drawing its water from the River Clyde and its tributary Stonebyres Linn. Now, like the Galloway scheme, it is owned today by Drax, having been acquired as part of Scottish Power's hydropower estate way back in 2018. Major infrastructure projects, of course, require their own statutory provisions. The Galloway Water Power Act became a statute on the 10th of May 1929, establishing the Galloway Water Power Company. Its first chairman was Lord Meston, another Scot. Now, to give him his formal title, he was Baron Meston of Agra, which is in India, and Dunnottar, after the castle up in Kincardineshire. James Scorgie Meston was born in Aberdeen in 1865 and was Lieutenant Governor of Agra, which was part of the British Empire at the time, only returning to the UK in 1918. Now, amongst his other appointments, he was the Vice Chair of the Supervisory Commission for the League of Nations. That's the forerunner of the United Nations. And as the plaque here shows, he was also the Chancellor of Aberdeen University. Also on the board of the Galloway Water Power Company was Robert Brand, the Managing Director of Lazard Brothers. They underwrote the finances of the scheme. I can't claim that Brand was a Scot, but he was well connected. His father was the Governor of New South Wales in Australia, and Robert's wife, Phyllis, an American, was a sister of Nancy Astor. Now, in 1918, Nancy was Britain's first female MP to take her seat in the House of Commons. She was a strongly opinionated woman, whom in today's terms might make Margaret Thatcher sound like a socialist. Okay, I believe that's probably stretching credulity a little far. Now, the next stage for Galloway was the design not only of the civil and electrical engineering components to ensure it did what it said on the tin and generated electricity, but also the architecture of the principal infrastructure. Now, for the civils, who better to turn to than Sir Alexander Gibb and Partners, consulting engineers. Sir Alexander founded the company in 1922 after a very prestigious career. He was civil engineer-in-chief to the Admiralty, and he was the Director General of Engineering at the Ministry of Transport. Alexander served his apprenticeship with Sir John Wolfe Barry, and it was John Wolfe Barry and Henry Mark Brunel, that was Esteban Kingdom Brunel's son, who built Tower Bridge in London, and of course, up in Scotland, Connell Bridge, up near Oban. Alexander then modernised Rosyth Dockyard in preparation for World War I. He was of outstanding Scottish pedigree and outstanding engineer pedigree as well. Born in Broughty Ferry in 1872, he was 50 when he established his private practice. But he was the son of Alexander Easton Gibb, a civil engineer, and he was the great-grandson of John Gibb. He was born in 1776. Now remember, that's only 30 years after the Battle of Culloden. And that John Gibb had been a deputy to Thomas Telford. He designed Leith Docks and Lancaster Canal. And he also worked with John Rennie of Ken Bridge Farm, fame across at Greenock Harbour. 1936 was an outstanding year for Sir Alexander Gibb. Not only did he see his project at Galloway here completed, his other major project that year also opened. It was the Kincardine Bridge, at that time the largest road bridge in Britain and the longest swing-span bridge in the whole of Western Europe. Now, if you want something done, ask a busy man, is what they say. Sir Alexander was also president of the Institution of Civil Engineers that year. An institution's founding father, I needn't remind you, of course, was Thomas Telford, whose first bridge in Scotland was, of course, Tongland Bridge in 1804. Now, for the electrical engineering, William McClellan of Merton McClellan was in the driving seat. Not only a Scot, but a local lad to boot. He was born down in Pulnackie in 1874. William's business partner was a chap called Charles Hesterman Mertz, and you can tell he was of German Quaker origin, although Charles himself was actually a Geordie. And he started off as a chief engineer with the Cork Electric Tramway and Lighting Company across in Ireland. The pair of them got together as Mertz and McClellan just after that. Now, sadly, McClellan died in 1934, so he never saw his innovative work at Galloway come to fruition. He's buried near his home down at Rockcliffe, commemorated in a plaque. I have to say, to be honest, the plaque's in need of some tender loving care. But now, the structures on the Galloway scheme became hallmarks of modern architecture. Look at that. These are both at Tongland. This was the 1930s, so there was an element of post-Art Deco in the design. For that, we have to thank a British architect, Harold Ogle Tarbolton, who was the advisory architect to the scheme and a member of the Amenity Committee. Working with Sir Alexander Gibb, he was determined to give the structures some architectural flair. Now, I called Tarbolton a British rather than a Scottish architect. Why, I hear you ponder? Surely with a name like Tarbolton, he must have been of Scottish pedigree and surely of Ayrshire stock. But no, although he carried out most of his professional work in Edinburgh and throughout Scotland, he was actually born in Nottingham of English parents. He was known as Tarry Breeks, which is a kind of colloquialism for a sailor. I'm never very sure whether that was one of his pastimes. And his practice was based up in Edinburgh, where he was in partnership with Sir Matthew Montgomery Ochterlony, and he was most certainly a Scottish architect. And for an example of that arts and crafts style adopted and promoted by Tarbolton, we need only venture as far north as Ayr to what they call the Western House, designed in the 1920s, originally built for Ayr Racecourse for the use of the Western Club in Ayr. If you've been up there, and many of you sure have, it's now a hotel, and it still boasts the period features from the 1930s. The Galloway scheme was Tarbolton's first commission on hydro schemes, but in the 40s and the 50s, the team of Tarbolton and Ochterlony were the principal architects involved with the north of Scotland hydroelectric projects, particularly at Loch Sloy and the Tummel and Garry scheme. And it included that Pitlochry power station, which I referred to earlier. Tarbolton himself died in 1947, so he never saw all of these projects through to completion. Now, each of the principal buildings was painted white externally, which gave them a look of a composite estate. That's akin to the fashion on many rural estates, perhaps best evidenced by the Great Glen cattle ranch, just north of Fort William, with its distinctive yellow paintwork on each of the cattle sheds and the other buildings. Just where Joe Hobbs did his agri project way back in the 1940s. Several of the structures in the Galloway scheme are listed of architectural and historic importance, notably the Glenlee Power Station and its bridge, and the Tonglin Power Station with the Surge Tower and the Valve House. That level of statutory protection is an important reflection of how we respect our built heritage in Scotland. But it wasn't just the power stations at Galloway which received the architectural eye for flair. The dams incorporate a distinctive curve in them, not an engineering requirement, but it certainly adds a touch of finesse as a landscape feature. That's Clattering Shaws, of course. And clearly the Amenity Committee, responsible to the main board of the Galloway scheme, recognised the significance in promoting and conserving our heritage. Loch Doon Castle is a case in point. Prevent the rising water levels at Loch Doon submerging the castle, which dates from the 13th century. It was dismantled stone by stone from the island in the middle of the loch and rebuilt on the shore up at Craigmulloch Farm. But it's not just the built heritage which concerned the Amenity Committee. With the exception of ancient monuments, and most of the statutory provisions for designated sites in Scotland date from the 1940s. The Galloway scheme was also long before anybody thought about environmental impact assessments. However, due regard was paid to the natural environment, to the key habitats, to flood protection and important commercial activities, predominantly, of course, farming and fisheries. The River Dee is a salmon river, as you know, and key measures were incorporated into the scheme to safeguard the migratory nature of the salmon. Special passes, known as fish ladders, were built. Here's one at Tonglin, for example, allowing the fish to pass the dam. Construction began in 1933. It was a massive civil engineering operation in water resource management. Over 1,300 people, some people would say over 1,500 people, were employed, and the total cost was £3 million. By my reckoning, that's equivalent to slightly shy of £300 million today. What's more, it completed on time and on budget. How's that for project management? The £3 million cost tag represented a cost of £29 per kilowatt of installed capacity. Indeed, they were some of the least costly power stations ever built in the UK. And of that £3 million, £1.8 million, or 60%, was expended on the civil engineering projects. Time now to introduce another key character in our story of human endeavour here at Galloway. He's not a Scot, but rather a Kiwi, coming from New Zealand, born in Nelson at the north end of South Island in 1896. William Hudson, he was later Sir William, was qualified as a civil engineer. He was in his mid-30s, he was working in Sydney, Australia, and the Depression struck. Not a man to remain idle, he set about trying his luck in Britain, leaving his wife at home in New Zealand. Sir Alexander Gibb offered him the post of engineer in charge of construction on the Galloway Hydro Scheme. It was the largest engineering project of its kind in Britain at the time. Who could possibly say no? Hudson notified his wife of his success in typical fashion by telegraphic direction. Come to Scotland. Arriving at Tilbury Docks with their child in hand, she found another summons. I can't get away. Come to Galloway. Well, the husband and the family finally met up at Castle Douglas railway station, and he was to spend the next 5 years working on the project. And the experience of doing that actually grew his reputation as an efficient and a dedicated leader. And he completed his task almost a year ahead of schedule. Together with J.K. Hunter, he presented a paper on the scheme to the Institution of Civil Engineers in London, and quite fittingly, he won the Telford Premium Prize for that paper. Returning to the Antipodes, he reached the pinnacle of his career in 1949 at the age of 53. He was chief engineer on the Snowy Mountains Hydro-Electric Scheme, responsible for the largest civil engineering project ever undertaken in Australia. And I can vouch personally for the Snowy River Mountain Scheme because I had the pleasure of driving through that part of Australia way back in 2005. However, back to the 1930s and to Kirkcudbrightshire. Let's have a look at some of these impressive dams first, will we? Some used natural features to create man-made dams. For example, here at Tongland Dam was built across a deep and narrow rocky gorge through which passes the River Dee, as the Ken becomes when it goes out of Loch Ken. It impounds a daily supply of 13 million cubic feet of water. It's 950 feet in length, and it rises 70 feet above the original level of the river. At the western end, the dam utilises a steep cliff. It's more than 100 feet high, with the eastern end being a conventional sort of gravity dam of mass concrete. It incorporates 2 large floodgates, each of them are 31 feet high and 25 feet wide. Other dams in more open countryside were completely man-made structures. Here's Carsfad, with a power station below, spanning 1,270 feet across the River Ken in a magnificent horseshoe curve. The intake channel is on the left, that's the west side, channeling the water through sluice gates to the reinforced concrete aqueducts. Each of them are 13 feet 6 inches in diameter. The spillway channel is in the centre of the dam, you can see it there, and you can see the fish ladder also up behind the power station, allowing access for the salmon to pass the dam. Now, if you think that one's impressive, look at this. This is Clattering Shaws. Built across the Blackwater River Dee, this dam is 1,500 feet in length and is built on a curve of a radius of 3,000 feet. They had to excavate holes 20 feet deep to carry the foundations down to what they found as solid granite. Its construction created that artificial water body known as Clattering Shaws Loch. It's 2 miles long, the average depth is 31 feet, and it holds 1,250 million cubic feet of water. Now, one of the statutory requirements was that the river flow should not be allowed to fall below 12 million gallons a day at a point 7 miles below the dam. It's a requirement of the Reservoirs Act. It's called compensation water. Now, you see the outlet is in the centre of the dam. It consists of 6 feet long steel plate culvert through the dam, closed on the upside by a freestanding emergency gate. And the flow of the water is controlled by a mechanically operated needle or plunger valve. That's a schematic of it there. And then at Elliston Dam, photographs whilst it was under construction, the arch section of the dam built across the River Ken, 282 feet, built in a radius of 145 feet. Again, a great curve. It impounds 140 acres of water. There's a power station at Elliston too, as you know, one of 3 above the Glenlee power station. The clever bit is that the 3 power stations are built to operate in conjunction with each other, and they use the same water. Water from Kendoon Station, furthest upstream, flows into the 100-acre reservoir created for Carsfad. Similarly, the water from the Carsfad turbines is collected in the reservoir for the Elliston Station lower down. Together with the water from Clattering Shoals, which generates electricity at Glenlee, all the water from these stations helps operate the turbines at the southern end of the scheme at Tongland. How is that for the sustainable use of our water resource? And remember, ladies and gentlemen, we were doing that in the 1930s. Mention of Kendoon assumes that we would have reached the northern extremity of the Galloway scheme. Thinking about the topography in terms of water catchments, this is where it gets really innovative. For the Galloway scheme is not restricted to the Ken and the Dee catchment. Water is also harnessed from Loch Doon, which would naturally flow northwards into Ayrshire. And that enlarges the catchment by 50 square miles. The dam built at the northern end of Loch Doon raised the water level in the loch by some 27 feet and increased the surface area to 2,250 acres. Believe it or not, it stores 15,000 million gallons of water. The water in Loch Doon serves as a sort of additional supply for the power stations where the local sources of water are running low, typically during the summer months or periods of low rainfall. The linking tunnel through Kildonnell Hill, which forms the watershed between Loch Doon and the Ken catchment, discharges to a small burn to the east of Drumjohn and the tributary of the water of Duke, hence to Kendoon Reservoir. The construction of a 7,000 foot, that's 1.25 mile long tunnel, was problematic in several sections due to the substrata. It's moraine or, as you know, glacial till material. And compressed air had to be used for the excavation process over short sections of it. The tunnel floor and the walls are lined with concrete, but for most part of that tunnel, the roof is formed of natural rock. There's a 200-foot long, 14 feet 2-inch diameter reinforced concrete aqueduct on this part of the scheme too. Here it is under construction. Actually, the water resource management is even more ingenious than I've just described. For the sources of the water of Duke, which lie within the Ken watershed, are diverted by a dam into a second tunnel, which conveys the water to Drumjohn and thence through the Loch Doon tunnel back to the loch. But ladies and gentlemen, that these tunnels and aqueducts were an engineering feat. They are dwarfed in scale by the Glenlee tunnel, which channels the water from the reservoir created at Clattering Shoals. The tunnel was bored. It was bored using a drill and blast techniques. It was built from either end simultaneously. Just as well they met up in the middle, isn't it? Because there were no computers or laser beams or any of that sort of nonsense then. It was done with theodolites, but it was all long division. The maximum rate of progress was about 100 feet a day. The tunnel is a horseshoe in section, and the change required due to the ground conditions. The tunnel at Glenlee is 3.6 miles long. That's 19,050 feet. I know you're all trying to work out in your head. Let me tell you, that's 4¼ times the height of Ben Nevis. And the diameter of the Glenlee tunnel here, 11 foot 6 inches. Ladies and gentlemen, that's 6 inches wider than the Glasgow Underground, the Clockwork Orange. And it's got a gradient of 1 in 350. Absolutely amazing. But it's not just a tunnel. To relieve the excessive pressure of water, which could result from a sudden closing down of the turbines at the power station, the tunnel incorporates a surge shaft, which is situated, it's about 700 feet from the Glenlee end. This is a schematic of it here. The surge shaft shows the scale of this piece of infrastructure. It's 142 feet deep, 24 feet in diameter. But more ingeniously, near the bottom of the surge shaft, a large chamber, 105 feet long and about 24 feet high, driven horizontally right through the rock. And that chamber accommodates sufficient water to keep the tunnel fully charged. The surge shaft is in practice a kind of overflow mechanism. Now, the project wouldn't have been at all possible without huge quantities of steel. The housing for the turbines are structural steel frame, and the massive floodgates are steel too. The pipe linking Glenlee Tunnel to the Glenlee Power Station alone is 1,700 feet long, 9 feet 6 inches in diameter, and it weighs 630 tonnes in total. Now, steel, of course, was a relatively new commodity in Scotland in the 1930s. The first major project had been, of course, the Forth Bridge, the railway bridge in 1890. That was the brainchild of this man, Sir William Arrell. And it was the Arrell Ironworks in Dalmarnock which supplied the steel for the Galloway scheme. It wasn't Sir William himself, of course. He died in 1913. The steel pipe connecting the Kendoon Power Station with the reinforced concrete aqueduct feeding the Blackwater Dam here is 700 feet long. The diameter is 13 feet 6 inches. And these sections were delivered as half cylinders, about 8 feet wide, and they were riveted together in situ on the site. Yet another piece of absolutely fantastic engineering is evident at Glenlocher Barrage, just outside Castle Douglas. It raises the level of Loch Ken by 6 feet. It's 338 feet long, 35 feet high, comprising 6 sections, each of which is 45 feet wide. The opening gates, there's 3 at 10 feet and 3 at 9 feet. Each of them weighs 11 tonnes. Now, they were transported from the maker's works up at Dalmarnock to the site, complete on a special lorry, whose overall length with the load was about 70 feet. You wouldn't want to get stuck behind that on the A75, would you? But to put that length in context, the Department of Transport's guidance on the maximum recommended length for an articulated heavy goods vehicle, incorporating a low-loader trailer, as shown here, published in 2017, was 18 metres. To do a quick conversion, that's only 59 feet. The one at Galloway was 70 feet long. When it came to the electrical engineering, the beating heart of the scheme, the statistics around the turbines make impressive reading too. Carsfad and Earlston each have 2 vertical shaft reaction turbines, normal output about 6,000 kilowatts at 11,000 volts. When they were built, were the only 2 power stations in the whole of Scotland which could be operated without any attendance. The whole thing was centred at Glenlee Power Station. Kendoon Power Station, capacity 21,000 kilowatts. And the Tongland Power Station has 3 turbo alternators. They're each designed to give a continuous output of 17,500 horsepower. Now, that load translates into a quantity of water passing through of 46 tonnes per second. Absolutely, 46 tonnes a second. These turbines were the largest of their kind installed in Britain when the power station opened in 1935. And now the 5 power stations together at Galloway, 102,000 kilowatts. But the project wasn't without several health and safety incidents. That's an area, of course, in which we've improved in leaps and bounds in the last 90 years. A memorial stone has been erected to the 5 fatalities and those 16 who were seriously injured. You may recall that I remarked when I spoke about the bicentenary of the Ken Bridge that it's so often the case that the plaudits for such projects go to the designer, the engineer, the architect. How seldom we remember the men who worked on these iconic structures, all of whom toiled long and hard, and some of whom gave their lives to bring the projects to completion. Now, you've seen a range of rather old photographs here today. I've relied for a number of sources for these, but not least a contemporary publication from 1937. It's most of the black and white photographs during construction came from this publication. It's called The Wonders of World Engineering. I'm sure you all have a copy of it on your bedside table. It was a kind of 1930s version of Look and Learn, you know? And its articles inspired a generation of children to become fascinated with engineering. Many will have gone on to great careers. It would largely be boys, of course, in these days. Quite a change from today, when we're lucky enough to have so many female civil engineers. The Galloway Hydro project appeared under the title Power from Scotland's Lochs, the second in a series which included vast contemporary engineering schemes from all around the world. Part 6, which this article appeared on Tuesday, the 6th of April, 1937. Would anyone like to hazard a guess how much it cost? Those with an eagle eye might notice the top right-hand corner, 7D, 7 old pennies. That's almost 3 pence in decimal currency. 7 pence in 1937, that I reckon is the equivalent of about £2.90 in 2026. That's less than the price of the Scots magazine. So exceptionally good value for money, I'd have said. Now, the Galloway scheme was generally heralded as a significant, nay, an iconic achievement. In the 1930s, here was Scotland harnessing the natural resource of water, a resource of which there is an abundance. There's more water in Loch Ness than in all the lakes and rivers in England and Wales combined. And they were doing that to generate electricity, a vital commodity to power the domestic, the commercial, the industrial needs of the nation. But not just this nation, indeed the UK, given the contemporary development of that national grid. We've seen that it's not only an engineering triumph, it also embraced the modernism fashion in architecture. It protected the natural and historic heritage of this beautiful part of Scotland. And it's still here, in much the same configuration as it was built in the 1930s. Proof, if proof indeed was needed, that good ideas last. But you know, not everyone liked it. Take the local writer, W.G.M. Dobby. His book here, Winter and Rough Weather, was published in 1938, and it includes Dobby's poem. It's called The Modern Raiders Galloway Water Power Scheme. I'm going to put the second stanza up on the frame. Here goes. A raider comes today who kills the glories of our glens and hills with unheroic acts and bills and private legislation. The company promoter's pen will damn the Duke and damn the Ken and damn the D, oh damn the men who plan such desecration. I just wonder, was Mr. Dobby the original NIMBY? Or, you know, ladies and gentlemen, perhaps worse. Perhaps he is one who exhorted the anti-development mantra, build absolutely nothing anywhere near anything. Build absolutely nothing anywhere near anything. They really are bananas. But you know, nothing does stay the same. Wear and tear happen to the best of us. Maintenance and renewal is essential. That can be achieved by asset management planning, and it often yields improvements in efficiency and effectiveness to boot. And you know, it's a very different world nowadays to what it was in the 1930s. The average annual rainfall in the area has increased by almost 4% in the last 90 years. The installation by Drax of what it calls its HydroMaster has brought its weather forecasting capacity and capability into the 21st century. Much has been achieved in Glenkens, not just by the hydro pioneers in the 1930s, but more recently through the considerable efforts of conservationists and a broad range of community interests. Many of you are here this afternoon. Witness the success of the Galloway Glens Landscape Partnership Project, ran for 5 years from 2018. Now, ladies and gentlemen, I'm very conscious of the 27 miles of new pylons which are to replace the outdated infrastructure, can no longer be maintained to avoid the risk of power outages, bringing the power from Kendoon down to Tongland. It's generated much angst, if not electricity. 7 years of debate, a public inquiry, and a decision by the Scottish Government in February 2025 to replace the existing pylons with new overhead pylons, rather than the call for underground cabling of maybe 5 or 6 sections, for which the Galloway Without Power group campaigned relentlessly. Now, some of you will no doubt be very disappointed with the Court of Session's decision last month that the bid for a judicial review of the case has failed. I've read the report prepared by Scottish Power Energy Networks way back in July 2020. In comparing those relative costs of underground versus overhead, the analysis shows a cost ratio about 4 to 5 times more costly for putting it underground. And I remember my time I was with Scottish and Southern Energy, SSE, the Hydro Board, now retired about 11 years, but when similar costing comparisons were undertaken for other schemes, most notably the Beauly to Denny line through the Cairngorms National Park, the cost of going underground was at least 6 or 7 times more expensive than the overhead pylons. That cost differential was considered prohibitive, and only very short sections, actually Granton-on-Spey around Bynethy Bridge, were actually laid beneath the surface. But whatever the arguments, above or below ground infrastructure, what must be evident to all is that the success of the Galloway Hydro-Electric Power Scheme is enduring. Its importance as a national asset in power generation has the longevity, not just for the 90 years since it opened, but actually this investment in new pylons means that it remains and will remain a hugely important asset for at least another 90 years. I would argue that given the challenges of climate change, the drive for net zero, etc., using our natural resource of water to generate electricity is the very essence of sustainable development. Ladies and gentlemen, join me in celebrating the Galloway Water Power Scheme on its 90th anniversary. Could I ask you to raise a glass to Uska? Thank you.